All right. Last lesson in this packet. So lesson 5 says more graphs of functions. So we are going to be looking at graphs again, but it's a lot faster, this one. And we're going to be talking about functions again. But the first thing is to look at these 4 graphs and decide which does not belong. So pick one of these graphs that does not belong, and like always on your paper, write down which letter and why. So pick one that doesn't belong and tell me why. All right. Somebody that chose A. Why does A not belong? Yes, it can. Okay, so what would your answer for A be?
It goes down and rises again.
Okay, so perfect. If you chose A, you might have said that the graph goes down and then rises again. Absolutely. Anybody also choose A and want to tell us why? Okay, so that's a big one, would be that we have a decrease and then an increase. Somebody 5th period said that it's the only one where the graph touched the x-axis. Okay, that's another option. How about B? Anybody choose B that wants to tell us why? Okay, Akio, why would you?
Different answers.
Huh?
Like you have 2 different answers. I said, let's say 5 on the x-axis. It could be 2 different.
Okay, beautiful. So we could have 2 inputs or 2 outputs for our input.
Teachers and students, please pardon this interruption. At this time, we are having a soft lockdown drill. Once again, there is a drill. We are having a soft lockdown drill. Teachers, please follow the instructions for a soft lockdown drill.
That's why I just mentioned.
So, if you guys don't know already, soft lockdown, business as usual. We just have to lock the door. And then we have to pretend that we're sealing it. Yeah. So, just in case you're ever asked, Ms. LeMay is demonstrating how she would seal up the door. Just in case, that's more for like if there's a chemical in the air or something explodes and there might be some sort of particles in the air that we need to protect ourselves from. They like shut down all the air conditioning so that, the air vents don't pump anything that's in the air out, but we seal up the door to kind of keep all the icky out. When I was in 6th grade, a plant out in Henderson blew up. It's called PepCon. It was like a chemical plant, blew up. And so the whole city went on like a lockdown. It was crazy. Everything turned dark. We all had to get under our desks. It was wild. The whole siren like sounded in town. It's crazy. This is why we practice. I don't even remember if we sealed anything. I don't know. I lived. I don't know. Okay, so for B, we have 2 outputs for an input. So for example, you said, what if x was 5? That was your example, right? So if I said that was my x value of 5, it would have 2 y values, right? Which means this would not be a function because I inserted a 5 into the machine and got one number, and then I inserted a 5 into the machine and got a different number. Not a function. Okay, so B was a big one. A lot of people won't pick it. I know which one most people pick, but the main purpose for B being on the paper is to kind of revisit that. C. Anybody choose C? Ah, here we go, Stephanie, why? So C is the only one that is made up of some straight lines. Yes, right? We have straight lines here. The others are curves. Eric?
Only one with sharp points.
Only one with sharp points. So we kind of have like vertices, or we have points on the ends. Yep. Kim?
It doesn't move, or it does move, but it doesn't go up until three, and then it stops moving or goes straight.
Okay. If you think about like science, right? If this was a scenario from science, you would have maybe like depending on what everything was labeled, like the car's not moving, like the car is stopped, right? The car is stopped, and then the car moves, and then the car is stopped again.
It's same speed or
Same speed, like constant speed.
constant speed, yeah.
Yep.
Constant speed and then accelerating.
There you go. Or constant speed, accelerating, constant speed, right? So you could absolutely have some sort of scenario like that. Anything else for C? All right, and then D, I'm guessing a lot of people chose D. It kind of stands out. Scott.
It's the only one that goes up and down.
Okay, it's the only graph that has like increases and decreases, multiple. So we have decrease, increase, decrease, right? A had a decrease and an increase, but D kind of goes back and forth. Okay, yes? Only has points labeled instead of, they're not connected, right? So we only have dots. I think I heard dots over on the other side. I know I think fifth period, a lot of people picked letter D. Fourth was kind of like you guys, a bunch of people picked C, a bunch picked D. I would suggest if you chose D because it kind of stood out and it was the quickest one you could see, try to start, at least for our last few lessons, try to start thinking of the not the obvious reason, right? So if you pick D because it was points only, that's 100% true. But maybe C, is there another reason that doesn't fit? Can you kind of push yourself, kind of like what Skylar said, where it goes down and then up and then down again? Or the one that sticks out to you first, don't pick that one. Find a reason for a different one. Because as you know, there's a reason for all of these, right? So start kind of trying to push ourselves. Yes. Okay, starts at the top of the y-axis and ends down on the x. Yep, absolutely. Okay, really good job, you guys. That was the best one yet of people's ideas of how these are different. Very good. All right, so like usual, this just brings up a little vocab, does a little review for us. I'm supposed to fill the thing out too. Okay, next one. I totally forgot about my.
Oh my goodness, there could be guests.
How many? Yeah. Was anybody out? Was anybody out there?
Oh, yeah, they already came in.
Yeah. Oops, I didn't do my minutes. Okay. Next page. Take a look at this graph. We have a graph that shows the temperature between noon and midnight in one day in a city. We are going to answer some questions based on the information, but the time at the bottom is afternoon. So even though our graph starts at 0, this is really noon, and this is midnight at the other end, okay? So I want you to look at numbers, well, 2 is blank, but 1, 3, 4, and 5. So I want you to answer numbers 1, 3, 4, and 5 by yourself. Take about a minute or so. Look at the graph and see if you can figure out an answer to what the questions are asking. So get as many of them done as you can. 1, 3, 4, 5. Okay, so 1, 3, 4, 5, which ones can you get done? Right, so you can use the graph and see if you can get the answers.
Teachers and students, please pardon this interruption. That concludes our soft lockdown drill. You may resume classes as normal.
All right. Number 1, is it warmer at 3 or 9? So somebody tell me, is it 3 or 9? Is it warmer? Eric. Eric, is your hand up or no? Was your hand up? Which is warmer, 3 or 9?
It was, but.
Oh, okay. Skylar. Skylar says 9. What do you guys think?
Yeah.
Yes? So number 1 is 9 p.m. So if we look up at where 3 o'clock is and 9 o'clock, 3 o'clock, it's almost 55 degrees. 9 o'clock, it's almost 56. So almost 56 is warmer or higher of a temperature than almost 55. Okay. Number 3, approximately when is the temperature the highest? So Eric. 5 p.m.? What were you going to say, Mo? No. 6. Q? 5:40.
Wait, do we have to get the actual, like, if it was like 5:55 stuff, we have to get that?
Well, we do want to approximate, right? And they don't give us much in between. Like there are no lines in between. All we have is 5 o'clock to 6 o'clock. So we can't get an exact, but I do know that this point right here will be the highest, right? And it definitely is not 5, and it's definitely not 6. We want to approximate, but we also have to be reasonable because an hour is a long time. We all know when we, those bells ring about an hour apart, right? So if I look at where my point is, and it is kind of far from my axis, so we are kind of estimating, but I would say it's at least a little more than halfway, right? So if I kind of travel down as best I could, it's a little over 5:30. However, maybe 5:40, 5:45. If you said 5:30, it wouldn't be too bad. 5 o'clock's close, but like 5 or 6 definitely wouldn't be the answer. I think if you got close to something reasonable, you're fine. If you said like 2 o'clock, I don't know what you're looking at, right? That would be wrong. So for number 3, somewhere around 5:30, 5:45, 5:40, something like that. Okay, somewhere around those times. Definitely not 6, definitely not 5, somewhere closer to 6. Number 4, find another time that the temperature was the same as it was at 4 p.m. Okay, so think about what the temperature was at 4, What's another time that's the same temperature, Eric?
Oh,
8?
7:50.
Oh, okay. Well,
Yeah, I said
8, 7:50, 7:40,
Yes.
7:40. Okay, so we've got somewhere close to 8. So if we look here, 4 o'clock, it was a little over 57 degrees, right? If I travel over to the right and get as close as I can, it's somewhere right around there would be the same. And it's close to 8, but not quite, right? But as long as you're close to 8, you're okay. So 7:50, 7:55, even 8 would be, I would think, reasonable. So somewhere around 8:50, I'm sorry, not 8:50, 7:50. Right, 7:50, 8 o'clock, something like that. Number 5, did the temperature change more from 1 to 3 or from 3 to 5? What do you think, Eric, and then Akil? 3 to 5, what do you think? 1 to 3, how many 1 to 3s? Couple people, how many 3 to 5s? Okay, and then a bunch either too afraid or weren't sure what to do. So let's take a look. So from 1 to 3, let's see how the temperature changed. So if we start at 1 o'clock, and we're going to go to 3 o'clock. And if I look at how the temperature changed, right, we want to come over to somewhere like right around there, right? I started just above 50, right, because that's 50 here. Just above 50, and I end up just below 55. So about 1, 2, 3, let's see, 1, 2, 3, 4 and a little bit. What is it, almost 5? Is it close to 5? So somewhere around 4 or 5, right? 4.5, something like that. I feel like I counted wrong in 5th a little bit. It's tricky when we're estimating and we're jumping and we don't have our marks in between. But if I look and I kind of bump myself to the whole numbers, it goes from 50 to 55, right? So it's somewhere between 4 and 5. Now, if I look from 3 to 5 o'clock, here's 3 o'clock again, and here's 5 o'clock right here. If I try to measure my distance, I don't know. If I look here, that's about, oh no, that was 4 o'clock, sorry. I'm supposed to go to 5. Sorry about that, guys. So ignore that. So it's close to 55 here, and it's at 58, so it's about 3. Those little squigglies are, say, approximately. So that's about 3 degrees. So even though it's not perfect, it's pretty obvious that this temperature from 1 to 3 did change more than the temperature from 3 to 5. Okay, so from 1 to 3, it was around, 4 or 5. Between 3 and 5, it was around 3 degrees. So 1 p.m. to 3 p.m. is the winner. Okay. Now we're going to come back to 6 in a second. We're going to jump to number 7, and then we'll come back to 6. When the input for the function is 8, what is the output? Okay, now if we remember from the review of lesson 4, we talked about x and y coordinates and inputs and outputs. And the input is our x coordinate, the output is our y. So make a little note that the x is the input and the y is the output. So if the input is 8, what's the output? Now remember, our input is the x. So go on your x axis and find 8. And look up and see what would the temperature be, because the temperature is y, that's our output, right? So when the input's 8, what's the output, Carlos? 57? What do you guys think? You agree? I do too. So at 8 p.m., the inputs or the output is about 57. Actually, it looks like it's exactly 57. So when the input of the function is 8, the output is 57. What does that tell you about the time and temperature? Well, that tells us that at 8 o'clock, the temperature is 57 degrees. So at 8 p.m., the temp is 57 degrees. That's where they get interpret what this means. What does it mean for the input to be 8 and the output to be 57? Well, that means at 8 o'clock, it's 57 degrees. And the reason I know that is because I just looked at the graph. My input is 8. My input is time. When the time is 8, the temperature is 57. So I just used all the info it tells me on the graph. All right, number 6 is something with the function wording that I want to kind of come back around to and talk a little more about. And I'm going to have you guys add something to your paper. The question says, does the graph show the temperature is a function of time or time is a function of temperature? So there's some wording that we've kind of talked about on other lessons and kind of throughout different parts of the notes that I want to kind of go back to. You don't need to change in your notebook or your note packet, but if you guys happen to remember back to lesson 2, on lesson 2, we went through and it was the first time we made function machine rules. And we said, if the person is 5.5 feet tall, do you know the height? The input's 5.5, the output is 66. And we went through and we made some machines. And then on the next page, we wrote down some words. Well, what depends on what? Okay, so if we look at the height, person's 5.5 feet tall, do you know the height? The height in inches depends on the feet. And we went through and we got to the point that we said the output depends on the input. The output depends on the input. Every single time the output depends on the input. I think we even put that in your notebook. Output depends on the input. Okay? Then we talked about dependent and independent variables. The output is dependent on the input, right? So now we're going to take those words and help us figure out what that means for these type of statements where something is a function of something else. Okay, so in some of the empty space you have down here, it's going to take us a second to get there, but we're going to go through and we're going to write a dependent statement like I just showed you guys in the packet here. And we're going to get that to the point where we can answer number 6. So kind of stick with me. It's going to take us a minute to get there. So I want you to write the output is dependent. Let me move this, sorry. The output is dependent on the input. The output is dependent on the input. Output is dependent, input is independent, right? The output is dependent on the input. Now, what this means is that the output is a function of the input. So the output being dependent on the input means that the output is a function of the input. So the output is a function of the input because the output is dependent on the input. Now, the last part before we come back around and answer 6. One of these values is the X and one is the Y. So is the output the X or the Y? It's the Y. If you're unsure, if it doesn't pop in your head immediately, take a second and think about it and say, okay, I have an output and I have an input. Input comes first in the alphabet, X comes first in the alphabet. The input is the X. That means the output is the y. O comes after I, y comes after x. So the y is a function of the x. The y is a function of the x. What's our y in this scenario here? Thank you, temperature. The temperature is a function of the x, and the x is time, right? So if our y is temperature and our x is time, that means temperature is a function of the time. So go back up to number 6. The temperature is a function of the time. Time is not a function of temperature. This is basically saying temperature depends on time. And if you think about it in just real life, because these aren't necessarily like real life words, you're not going to walk over and say, the temperature is a function of the time, unless you want to sound fancy or smart or you're having like a mathematical conversation. The way you can think about this in like day-to-day life would be if you went up to somebody at home or whatever and said, what's the temperature going to be like tomorrow? There's a very good chance the person's going to say, well, what time of day are you talking about? Are you talking about the morning? Are you talking about the afternoon? Especially right now, right? Because the temperature is different in the morning than it is in the afternoon. You leave the house in a hoodie and then you're hot by the time you're going home from school, right? So because if the temperature depends on what time it is, that's why the temperature is a function of the time, okay? Temperature depends on the time. And that's something we'll practice a little more tomorrow too, okay? Flip the page. And now we're looking at some information about garbage. Some shocking information, actually. The graph shows the amount of garbage produced in the United States each year between 1991 and 2013. Yeah, you guys seen Wall-E, right? Whew. It's about to get crazy with all this garbage, right? The graph shows the amount of garbage produced in the US each year from 91 to 2013. So what you're going to do is you'll see the different dots. Now the dots just show when data was collected. I want you to answer A, B, and C on your own. So you're just going to look at the time periods and answer the question that they ask. Okay, so do A, B, and C on your own. All right, so did everybody get increased for A?
Yes.
Yes. So for A, we're looking at 99 to 2000, and of course we don't have any markings here, but we can kind of estimate what we're looking at. So for this section here, I had a lower amount and it went to a higher amount. That's an increase. B, 2005 to 2009, we're looking at somewhere around here. Now, if you said that it increased then decreased, that would be completely acceptable. Or you could look at it from the beginning to the end. From the beginning to the end, it definitely decreased, right? Part C, in between 91 and 95, the garbage increased for 3 years. So if we look at 91 to 93, or excuse me, 95. So 91 to 95, it increased for 3 years and then decreased the 4th year. Okay? You describe how the amount of garbage changed from 95 to 2000. So hopefully from 95 to 2000, you said that it decreased a little bit for a year and then it increased. Okay, so decreased a little and then increased is hopefully what you said for C. All right, any questions on that one? Pretty simple, just reading a graph. Okay, last one we're gonna do is on the back side. Now we're looking at recycling. The graph shows a percentage of garbage that was recycled between 1991 and 2013. So percentage recycled. Answer A and B. When is it increasing? When is it decreasing? You don't have to find all the times, just find one. So find one period of time where the recycling was increasing and one period of time where it's decreasing. So give me a range of years. When did it increase? When did it decrease? All right. So you had multiple options of when you would have the increase or the decrease. It looks like from like 90 to maybe 2000 or 1991 to 1996, we had an increase. We also had an increase right about there. There's another increase. There's another so there's a bunch of different increase times you could have picked, right? For decreases, we have a little bit of a decrease here. There's a little tiny one there. There's another itty bitty one there, and there's a nice big one there. So there are a couple different times you could have picked. As long as you pick something, you're good. All right. So tomorrow we're going to do the summary for lesson 5. For now, what we're